All right, the live stream has started. We will start in a minute, just a minute. Awesome. Thanks a lot, folks, for joining today. Today, we have an interesting talk by Carson Anderson. He works at Weave. He's part of the platform engineering team at Weave. And he's doing platform engineering before it was famous as platform engineering. Like he's the person who has been doing SRE, DevOps, and platform engineering before the word was cool. One interesting thing about Carson is also that he is the person who has created a video on demystifying Kubernetes, and that is the most viewed video on the CNCF YouTube playlist. So I'll just post a link to that video as well, so that we can check that out. But today Carson is going to talk about how they implemented SLOs, tried multiple times, and then uh, get it working at the end. And we'll see the story, how that evolved over time. And feel free to ask any questions. Just post them in the comments. I'll be happy to take those during the discussion. The idea is to keep it interactive as much as possible. But yeah, I'll hand it over to Carson. Over to you, Carson. We can get started.
So, like you said, my name is Carson Anderson. I call myself the DevXO at Weave. It's a made-up title. I work on the developer experience team. You could call it platform engineering. Like you said, we did it before platform engineering was even a term. I work on that team sort of as the person that makes it happen. We have big plans, and my leadership looks to me to just make it so. So you're here, and I'm here to talk about how we implemented SLOs at Weave at scale for all our developers, and how we did it wrong, and eventually right. It's great to be able to do this talk. It's also really hard because it's essentially 30 minutes of me eating crow and saying how many times we screwed up. But I hope you have some takeaways from here that kind of teach you what things to use and what things not to use, and kind of some pitfalls, and get you to the right way without you having to do it 4 times wrong first. I am on GitHub at Carsonoid. I'm on Mastodon at carsonoid at kind.social if you want to join up with me there and follow what I'm doing. I will do one, it's not a plug, I just want to say I do work for Weave. If you're in the cloud native space, this is not the Weave you're thinking of. We work with small businesses, we do communication software. None of the stuff I'm talking about is anything we have any stake in, right? We're end users of all of this stuff. I just use a lot of it, and I want to help you understand Prometheus and SLOs. I'm not here to pitch anything, but do check us out if you're curious about us. So I'm going to start out and say there's good news and more good news. The good news is most of this talk is a story. You're going to see a lot of kind of in-depth technical stuff. I'm going to sort of breeze by a lot of it. I'm going to try anyway. And the good news is it's going to be nice and quick. The other good news is if you want excruciating technical detail, there is a blog post. So you can go to engineering.getweave.com to find blog posts for a lot of blog posts about the things we're doing at Weave in engineering, and talks that we're giving, and just kind of what we're up to date with. And there is a companion post to this talk that basically covers the same content, but it really, really breaks down everything in detail. So if I show you a Prometheus query and you're not quite sure how it works, or you want a little bit more detail, odds are really good that if you go to this blog post, you're going to get more detail on whatever you're trying to find out. I have one more link, and there's some big red asterisks here, and I'll tell you why, but there's another link to another article in this blog. Years ago, I did a presentation at a local meetup about the very, very basics of SLOs and the basics of SLOs in Prometheus. The first half of this presentation is really good. It holds true. It explains histograms and how SLOs work and how you can think about SLOs and how they work with Prometheus. The second half is one of the wrong ways that we did it. I was so proud in this talk a couple years ago, but that turned out to be one of the wrong ways. So I would encourage you to go to this, watch the first half of that, and then just ignore Carson. He's not as smart as he thinks he is in that second half. So let's talk a little bit about where it started, why we even wanted to get to SLOs at Weave, and why they even came up. We have a lot of data already at Weave. We have tons and tons of data. We have metrics. We have dashboards. We have a lot. We have stuff like this. And this isn't blurred out intentionally, because if you show an executive or someone in leadership dashboards like this, and their eyes just bug out and they go blurry, and it's just too much. They can't really look at this and understand, well, is the service healthy? Like, are we hitting what we expect normal operation for the service? Are we not hitting that? Like, how much user patience have we burned up? Is this good or bad? I don't know. So we needed something that was simpler, something that kind of reduced services down to the bare minimum of kind of what they look like from the outside, and kind of trying to judge normalcy. So this is where SLOs come into the picture. If you don't know, SLO stands for Service Level Objective. This is not something that we have invented. This is straight out of the Google SRE book, and I will give you plenty of links to those in a second. We're reading the SRE book, and they had this idea for service level objectives, and we said, let's do this. This is a perfect way to condense all that data into a number or a few numbers that we can get at a glance to tell the health of a service. So what is one, right? If we hop over, and I have two definitions for SLOs on here. One of them is right out of the SRE book. Again, it's public. I say book. You can buy it in physical form, or you can just go to sre.google and read the whole book. Like, you don't have to buy it. But out of that, they have this definition of what a SLO is. I'm going to condense it more and say, really, you can think about an SLO as a measure of normal performance for a system. Like, we're saying we expect a service on average to perform this way, and you can kind of tell if you're hitting or missing that objective. And we'll get really into detail of how we do this here in a second. But that's the definitions of SLO. Here are the couple more links. Again, you can just go to sre.google, or you can go to these links if you want to go to both the book part where it explains SLOs in great detail, or the workbook if you're trying to implement them. It's a great place to start as well. Like, these are really, really great resources, and it's what we used to start from. So let's talk about hard objective, right? The objective part of a service level objective is something like this. Really easy to understand, a sentence. 99.9% of HTTP requests will complete without a 500 level error. This is usually scoped down to a single service or a single piece of a platform, not the whole platform. But this is really a sentence. It's an objective. It's easy to understand what you're going for. So what we would like to do with our SLO system is measure whether or not we're hitting this target. So let's talk about what the vision was at Weave and some of the things we did right. Right from the start, our vision was we're gonna have users fill out these objectives in sentence form, right? Fill in the blanks, so that when you look at your service and you're configuring it, you know exactly what you're signing up for when you're setting your objectives. You're saying, here's the service I'm working for. It does this in the platform. Here are the objectives I intend to hit. And we started out our SLO system with focusing on just two things, gRPC and HTTP metrics, because that's the bulk of our services. We already had a lot of good metrics for that, and that's what we wanted to focus on for our objectives. You can do SLOs on pretty much anything, but we are really focusing on those two things. So the user would pull up our UI, they'd fill out these sentences, they'd hit save, they would deploy, and at the end, what we wanted at the other side of this for the developer was something like this. We wanted a dashboard where we could show the developer this, and we could show management this, and they can at a glance see, like, okay, here's your objective. How well are you hitting that? Are you 100% hitting that? Are you hitting that only 50%? We'll talk a little bit about this idea of an error budget here in a second, but this was the goal, right? Fill out the sentences, hit deploy, get the dashboards. Don't worry about how it got there, right? This is the kind of the core platform engineering. So we're going to give you these powerful tools, do a lot of things under the hood, not make you have to think about them too much. So I've been showing this idea of an error budget, right? And this really goes hand in hand. You'll see how this fits with the objective statement, and you can calculate how much of a budget you have remaining. And this calculation is really simple. You say, I have a number of errors I'm allowing to happen. I have the numbers that have actually happened. Divide that by the number that I'm allowing, and you get a budget remaining. This really makes sense when you plug in real numbers. So let's take some real numbers and use them. Let's say we've got a service. The service has 10,000 total HTTP requests in the last 28 days. We're going to say all of our objectives are 28 days of range. So 10,000 total in 28 days. And if we look over those 10,000, 20 of them have had a 500 level error, right? So let's take that, plug that in with our 99.9, which gives us 0.01. And we can say that we've budgeted for 100 failures, right? 99.9% must complete without 500. That means if we've had 10,000, we're going to allow 100 failures and not call it a problem. We're not trying to go for perfect. We're allowing for a certain amount of missing the mark. So if you plug those numbers in, you take the 100 we're allowing, the 20 that have actually happened, divide it by 100, and you get 80%. Says that, look, it's fine. You still have 80% of what you're allowing to happen. You can even go to 0 with an SLO error budget, right? If I have a budget, I had $10 that I'm budgeting to spend on food, and I spend all $10, that's not a problem, right? This is just a measure of how close you're getting to where things become a problem. So 80% of a budget is actually pretty good. Hopefully everybody understands the error budget part, because we're going to focus entirely on that calculation going forward. We have a lot of other calculations, but error budget was the main one I think illustrates our points for our scale problems. Some of the things we also had right from the very start were our existing Prometheus metrics, right? So from the start, we had a good UI, we had a good vision, and we also had really clean Prometheus metrics, and this helped a lot. We said we're focusing on HTTP and gRPC, and we have a standard set of 3 metrics for each of those that are basically the default turn on metric tracking for Prometheus for HTTP or gRPC, and you get these 3 metrics out, right? We had standardized labels and metric names, and this helped immensely. It would have been a 10x more complicated problem if we had to deal with lots of different kinds of metrics, names, and values. So these are the existing metrics we had. Let's talk a little bit about scale. I won't read all these numbers, but suffice to say, between all of our services and all of the replicas of those services and all of the cardinality of even just those 6 metrics, a single query to get an error budget for 28 days would have to parse about 864 million data points per day. So if you 864 times 28, you can see that we're getting a lot of data just to look at one number, just to say, oh, over the last 28 days, what's our remaining error budget for this service? And the scale is actually where all our problems came from. The SRE book is fantastic at walking you through how to calculate error budgets. They even have sort of Prometheus-esque like queries that you can just use. And it works until you hit this massive scale. So most of our problems came from scale. Let's talk about our first attempt, right? Now we're going to actually get into the story. And again, if you want to implement SLOs yourself, I would encourage you not to. The only real part you have to pay attention to if you want to do this yourself is the end result, where I talk about what we're doing now that actually works. But we are going to cover all of the attempts that we got through to get there. So the first thing we did, we read the SRE book and we said, well, look, let's just try calculating SLOs for everywhere all at once. So we did that. And I'm going to do this a few times for each attempt. I'm going to put the formula there at the top so you can kind of see what we're doing. So we made this query, and this query is gnarly, but it worked. You basically take the number of requests that I'm just doing HTTP. You can extrapolate this to gRPC by changing metric names. Take the number of HTTP requests that have happened over the last 28 days, times it by our factor, right, our 0.01, which comes from our 99%. We're going to subtract from that, and this is where we got weird, and this is a big mistake we made early on. We had problems where we would say, well, if we want to find all of the requests that had a 500 level error in the last 28 days, if a service had no 500 level errors, Prometheus would not have a metric. And if you try to do formula in a Prometheus query where one side doesn't have the same number of metrics as the other, it'll have no result. It won't return a 0. It'll return nothing. It kind of filters out. So what we did to be clever was we said, okay, well, let's get the total, and we'll subtract from the total, we'll subtract the ones that were good, and therefore the only ones that remain are bad. And by doing this kind of little shimmy thing, we're guaranteed that section in red never returned nothing. It always returned a 0 at worst. And it was silly, and I'll show you the better way. Just use vector 0. You'll see how we do this later. But this is how I'm just telling you the truth about how we started implementing this, right? And then we divide it by the bottom, and it worked. So the good news was that this query was 1 to write, and if you did it for very short time periods, like 5 minutes, it would complete. But as soon as you did this query for 28 days, it would never finish, right? Think about all of the millions and billions of metric series that it has to parse to do this. It's too much. So you'd plug this into the Prometheus, and Prometheus would fall over because it was just too big for our system. Another big problem with this is because it's one query for all the apps all at once, every app has to have that same 0.01 in there, meaning they all have to try to hit the same objective number, which isn't true. Every app should have its own objective it's trying to reach. So we did this. This was low effort, but it kind of worked. Let's go to attempt 2, where we took that big old query and made it a little smaller by doing it one service at a time. So this is going to look very similar. We went ahead and have the same formula, and this query looks almost identical. I will point out that the difference is that if you look at the timer count, we are actually focusing down. We're saying, okay, this is the query for the feature flag service for HTTP, and we're going to filter our metrics to just feature flags. And we'll generate one of these queries for every single objective for every service. That's not a big deal. We already had a system where we could just auto-generate queries based on some input. So making lots of queries was no big deal. And this is got to be a lot smaller, right? You're not looking over 28 days of every service in the system. You're looking over 28 days of data for one service. And the good news was that query would complete. The bad news was it would only eventually complete. So you have, on average, 8.5 seconds for one result. So you imagine if you put this query into a dashboard, for every single point on the dashboard, it has to run the query, 8.5 seconds, draw, put a dot. Query, 8.5 seconds, put a dot. So by the time you've charted out even the last hour, you've taken up minutes just to do one line. So we couldn't get to the vision, right? This would work, these queries would complete, but if you want to plug it into a dashboard, the dashboard was unusable. So we knew this still wasn't going to work, but we are getting closer. And this is, and spoiler alert, our final solution ended up being very close to this in the end. But we were having problems. So we said, okay, we need to handle this dashboard problem. And one tool that is really, really powerful and is both the thing that we're still using that solves our problem and the cause of two of our issues are Prometheus recording rules. So before I go to attempt 3, I'm going to explain recording rules briefly. So a Prometheus recording rule is actually really simple. It's a Prometheus query where you say, okay, Prometheus, every X period of time, run this query, take all the results you got, and save them under a new name. That's it. And it's really, really useful because it allows you to distribute the work of calculating something, save that result back into the time series database. So when you want to chart it, you just chart the pre-calculated data. And I'll show you what that looks like. Right? Let's say I have my metric and it's got all these series, lots and lots of lines, it's a lot of data. Let's say I wanted to chart the sum of my metric. This query would be instant, but let's pretend that running this query and putting it into a dashboard takes minutes because it takes a long time. It would be really nice if I could say, well, instead of typing this in here and having Prometheus do the calculation every time I pull up the dashboard, I'd like to have Prometheus run this query and save it under a new name so it's pre-calculated data. And that's what a recording rule is for. It's really good at this kind of stuff. So you take your query, you say, okay, Prometheus, every 1 minute, run this query, take all of the results you have and save them back into your database under a new name at the time point that you ran the query. Really, really useful, fantastic tool, but we misused it a lot. The nice thing is once you do that, you can plug that new recorded metric name into Prometheus or into anything and chart that without any calculations, right? You're not doing calculations now because they've been done a little bit at a time every minute. You're just charting the number that already exists, right? So if you have a lot of queries that take 8.5 seconds to run, it's no big deal if behind the scenes it takes 8.5 seconds if it saves it back, because then you just chart that one pre-calculated result. So hopefully you all understand Prometheus recording rules, and I'm going to tell you that our next attempt really, really misused them. You'll see it got really bad. We got way too clever. So we looked at recording rules and we looked at our existing query and said, hey, one big problem with our existing query is duplication. Look how many times we're calculating this one value. That is a lot of recalculations of data. We should extract that out and put it into a recording rule. And then we can just use that recording rule result like a variable in here, and we'll save ourselves time because we're just going to let the recording rule do it in the background. So we did that. We wrote a little recording rule that extracted that piece and put it into a new record. We also did this really bad thing where you see we're treating it like variables, and you shouldn't do that. We're calling the metric names these really long, hyper unique metric names. That's really not the right use of recording rules, but I'm just telling you what we did. So we did that, and then we went further. We said, well, if one thing is good in a recording rule, then let's calculate another piece. Let's take that previous result and put some math on it and sort it under a new result. Again, this is very natural if you're writing in a programming language. Recording rules aren't variables, though, but we're treating them like it. Then we did another one, and I'm going to breeze by here. And we did like 3 layers of recording rules, and we loved it because the final record rule in the group looked exactly like our formula that we were trying to hit. So it felt right because we did all these intermediary steps to get to something that looked like what we were trying to hit. And it worked, and it sort of worked. And it looked so pretty. We felt so confident about ourselves. So here's an example. Again, the blog post, I'm breezing through this. It really goes into detail about our thoughts and decisions and what we did right and wrong. But you can see we generate a lot of rules. This is all of the rules required to calculate one objective for one service. Having a lot of rules wasn't a problem, but our way of using multiple rules, and especially having rules relate to each other and use previous rules, was a big mistake. So we'll go into that. But the good news was that these queries would complete, and that at the end we did have that final single hopping back. We had this final rule name at the bottom. We could put SLO : feature flags, blah, 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 into Prometheus, and it would chart instantly because all the work had been done in the background over time. So that was great. The query would complete. You could run the final metrics in the dashboard. You could chart all of the SLOs, and they would all draw their lines, and it would basically be instant and performant in the dashboard. The bad was those really long, unique rule names made templating dashboards really hard. You shouldn't encode all that data into your metric names. You should use labels, and you'll see how we do that later. We also had these seemingly random spikes where the percent of budget remaining would be going smooth, and then it would spike up and come down, or spike down and come exactly where it was. And we couldn't explain this. I actually do in the blog post explain exactly why this is. It has to do with our abuse of those multiple recording rules. So that was a problem that just was really hard to explain to people. And some of these rules still didn't work. We had some apps with such high cardinality data that we just straight up could never query just how many requests they'd have over the last 28 days. And we didn't have a piddly Prometheus. We had a sharded, large, heavy Prometheus instance. Like, we were doing a lot of data. So this was just a sheer volume problem. So we looked at attempt 3 and said, man, this got so close, but we have all these problems. We need to go further. And we got to attempt 4 where we got it right. And I thought we got it right so much that I made the blog post and submitted it, and then I made a talk and gave sort of this same talk at Cloud Native Rejects recently in this past November. And I submitted that and got accepted. And then about 2 weeks before Cloud Native Rejects, I found out that attempt 4 was actually wrong, which is really frustrating and is very humbling. It's like you get so confident, you think, well, here it is, I'm right. No, I was tempting fate. We still had it wrong even with this final attempt, or this near final attempt. But what we did with attempt 4, again, this didn't work, but we said, okay, let's relook at recording rules and let's try to use them a little bit differently. Let's take the recording rules, and instead of doing per application rules, we're going to make a handful of rules that do more of what they're supposed to do, which is every minute we're going to look and kind of reduce. We're going to sum all of and you can see some of these examples. We take the HTTP timer bucket and we basically pre-aggregate it and stick it into a new record. So we're really massively, I mean, if you look at the number of series that one of the expressions would evaluate and compare it to the number that would be written in the result record, we were losing orders of magnitude of data, like, by condensing it. And it felt right, and it felt like this would work. And we put these in, and they're fine, but we misused them. And I'll show you how we misused them in a second. So we took the rules from before, and we went back to our step 2, and we said, well, let's not use all of the metrics. Let's use these pre-aggregated metrics, plug them in, and then chart that, because now this query is still big, but it's processing just a lot less data, so it would return. And we went ahead and still used recording rules. We fixed one of our major problems with recording rules. You can notice that now the record is just the single metric name SLO. We have this big expression, and then we use labels. So we say, record the results of this expression into a metric called SLO and attach these labels to the results. This allowed our dashboards to work well. We stopped doing that really silly long record name. So we got that part right, even in this still broken implementation. And it worked. Right? We would generate these, we'd plug it in, we could put this SLO metric into dashboards and chart the SLO remaining error budget for every service in the system. And it would show up instantly because it was all pre-calculated, and we felt really good about ourselves, and Carson made a blog post and submitted a talk. And everything felt great. It completed all the time, no more random spikes, everything was fast, and everything was easily templated. I felt so good about myself. And then we get to attempt 5, where I had to admit and kind of feverishly do this before the Cloud Native Rejects and come back and say, actually, no, we're still getting this wrong. And I'm going to show you the the critical part of what we got wrong here. So we had this is the query that we were using when I felt so good about it, where we were kind of using the pre-aggregated metric. And that, me keep saying the word pre-aggregated, is sort of a hint to what's going on here. And the problem was in the increase function. Not with the increase function, but we were using it in a place we shouldn't have been using it. If you look at the Prometheus documentation for increase, it says that increase should only be used with counters or things that look like counters, right? And this is if you've done any even medium amount of Prometheus work, you'll know that if you're going to use increase, you always have to do increase and then sum. There's a lot of stuff in there, but basically in order for Prometheus to account for changes in metric values for breaks in monotonicity, I always struggle over that, you have to increase first and then sum. You'll get wrong data. Well, if we take one of the expressions we are evaluating, we look at the record rule where that metric comes from, and we sort of put in its place, we replace that record rule name with a filtered version of the expression where it came from, you can kind of get a feel for what would happen, what you're doing. You're not really doing apples to apples. We thought we were taking our previous metric and subbing in the record, but we're actually pre-summing, right? It's effectively, if we use this record rule, we're effectively using data that's already been summed, then running an increase on it, then running a sum on it again. So this is our big problem. You would have cases where basically what this would manifest in our applications, where a service would have a bunch of long-running pods. Those pods would go down, and you would see the SLO error budget just sort of blip out because it couldn't actually account for that pod going out and coming back. Really, really important that you always increase before a sum, and using recording rules can sort of hide what's happening behind the scenes. So this little trick of substituting in your rule really, really helps. And I want to stress, recording rules are fantastic. We are still using them, but they can be the source of a lot of major pitfalls if you're not very careful about thinking about how you're using them and how they kind of relate to each other, especially if you use the result of a recording rule in a more complex query than just charting the value. So we went all the way back to the drawing board and said, okay, this one that we thought was so good isn't working. What do we do? And an engineer on the SRE team here at Weave said, you know, Carson, you do have duplication, and you can start by remembering that algebra exists and simplifying your formula. And I said, oh yeah, you're right, algebra exists. We can already get rid of one of our duplicate terms without having to even think about Prometheus or anything else. So that was one form of simplification. And so we took some of our new knowledge about how we can deal with lack of data in Prometheus, and we wrote a more concise and stable and understandable query than we've ever had before, right? So you take one, you subtract it by the number of errors. So if you go all the way back to our previous examples, we were always trying to find the number of bad requests by doing total minus the good, so we could avoid this no data problem. Instead, our final, the ones that are still working to this day, implementation of SLO error budget says, well, get everything that did have a 500 level error, and if you don't have any metrics from that, just return 0, right? So that you always have some data, and this query doesn't ever just blip out and show you nothing if your service has had no problems. And then you divide that by the total. So now we don't have any duplicate terms, right? We have one query once and another query once, and we're not doing any duplication. So this just basic algebra and some understanding of Prometheus queries more, we're able to reduce a lot of our duplicate terms, which was half of our problem. Again, that vector thing. So our final rule that we're using to this day, and these are the rules that we have plugged into our system that are working, is we record into SLO. We do this smaller expression that's a lot smarter. We use labels instead of these long SLO record rule names. And this really works. We're putting in our dashboard, the links that all of the screenshots I've shown of our dashboards are coming from these rules. But we kind of went backwards in our problem, right? So I'm going to hop back to the previous slide. This still has 2 places where it has to look over the last 28 days of data, which was the whole start of our problem. Scale, right? Like we had places where you just couldn't even get how many requests an instance. This bottom part under the divisor here couldn't execute for some services. That was still true when we went to these new record rules. So how do you handle this scale if you can't pre-aggregate if you can't use recording rules to kind of build on each other the way that we were doing the second time, what do you do about scale? You just need to handle that. And one option that we toyed with, what we didn't love, was sort of the I give, we'll just reduce the range, right? If we go from 28 days of data that we're looking at for our objectives, and we say, well, now all of our objectives only consider 14 days. It's not ideal. It's better to have, you kind of want to pick your objectives, and this wasn't what we wanted. Like, we could have done this. This would have reduced our problem, but then we didn't hit the target of the project. We didn't do 28-day evaluation periods for SLOs. But it would work, and it's really cheap and easy. If you're having scale problems, scoot that down and just deal with the fact that it's not exactly what you wanted. Another option would be to do record rules. Again, really, really understanding the right way here. And we're not doing the sum. This is the major difference. And this isn't what we went with, and I'll tell you why in a second, but this would be my preferred way to handle this. If you're having serious scale problems, you have queries that cannot complete because they have too much data. One very simple thing that you can do here is make a record rule, and you notice the expression there's no sum in this expression. This is why it's valid. We're just saying, hey, every 5 minutes, take all of the metrics you have under one name and resave them under another. That means that you're essentially downsampling. We're manually downsampling with a recording rule. We're saying, well, you may be scraping every 1 minute, or every 30 seconds or whatever it is, but I'm going to have 5 times less data by waiting till every 5 minutes to just resave under a new name, and then I'll query that new name. And that works. That, again, reduces the amount of data any query has to evaluate by 5 times or 10 times or whatever it is. You can sort of play with this downsampling interval to reduce the amount of data you're processing. This would be a completely valid way to do it. It has downsides in that you have to kind of deal with waiting for the next 5-minute period to go through. So if a service has a big spike of errors, it takes till the next evaluation of this rule for those errors to actually get counted in your SLO budget. Not the worst thing, but not the best. But again, really, really easy way to solve the scale problem with any metric is this sort of manual downsampling rule. And notice this is safe. It's safe to use these here, because if you do that little sub out trick where you sub one for the other, we don't suddenly get a sum in there that we didn't expect, right? We can kind of manually replace one recorded rule name with our filtered version of where it came from and prove that, yeah, it's safe. And that's a really neat trick. What we ended up doing, just to be totally honest, is a lot of this sort of came out of our migration that the SRE team was doing on their own from this big sharded Prometheus instance to a big Victoria metrics instance that we're hosting. And it just turns out that Victoria metrics and some of these other things they're Prometheus compatible. There's a lot of other ones besides Victoria. They're Prometheus compatible interfaces, but they have the benefit of coming after Prometheus, so they can kind of make their own restrictions and handle scale a lot better because you have the advantage of being the second implementer. So that's the change we made. With that change and the simplification of our queries, those two together meant that we didn't even have to do downsampling. We're able to just plug the new simplified queries into a system that was just better equipped for long-term metric querying, and we had our SLOs. So this has been a lot of talking, but I want to really, really stress I've had to go through a lot of ways of how we did it wrong. And if you're doing platform engineering, like, I think one of the key parts of being successful is treating your developers like customers and really having a solid experience, because throughout all of these iterations, all these nitpicks about how Prometheus and things work, our developers did one thing. They, at the very beginning of this journey, they filled out this form and they never touched it again. The form never changed. Our inputs never changed. Our promises to them never changed. We went through 5 iterations of implementing these promises, but they filled out a form, they deployed, and then at the other end, we gave them charts. And I think that kind of distills the essence of platform engineering is the developers never needed to understand any of how this worked. We learned this. We made the iterations. Every time we went from one generation of SLOs to another, we just told the developers, hey, SLOs are being generated a different way now. They're going to be more accurate, or they're going to be faster. You don't need to do anything. Just fill out the form, deploy, and look at the charts. And I think that was something we did really well from the start. My final thoughts on this, really, like, I can't, the fill in the blanks thing is really intuitive, trying to think about ways to present these tools to your engineers and to your developers in ways that are immediately understandable was really helpful. Again, having those standard metric names and labels for all of our source data was immense. If you're looking at SLOs and you're saying, I want to do SLOs, or I want to start doing these system-wide things with our metrics, make sure you have very standard names that'll make your whole journey faster. Do use record rules. I've talked kind of bad about them, but they're really useful. You'll notice our final solution uses record rules in 2 or 3 different ways still, but be really careful with them. Be really, really careful with them, especially when you take the result of one record rule and you use it in another query that's more complex, again, than just a slight filter. Do that little, take the result and swap it out with the filtered version to test that everything is still what you want, because it's really easy to try to treat them like variables when they're really not variables. They're metrics under a new name. So hopefully that was helpful. Thank you so much. I have a bunch of time for questions. Again, here's the link to the blog. If you want to see both all the articles that we have a lot of articles on platform engineering, and kind of you can go to the blog post and find that on the SLO journey and kind of dig deeper into anything I talked about today. And that's
Awesome. That was really awesome, Carson. We do have a few questions. So how was the time that was needed for basically each stage where you were able to evaluate and then figure out that, okay, we have to change and then come up with a new strategy?
So I'm going to paraphrase that a bit. So like, is the question how much time did it take between like each step? Okay.
Yep.
Yeah. So the time between the first one, where we just threw a big query at the world, and the per app generated one, that was basically instant. Like, we played with that idea. Like, we said, we're going to do SLOs. Let's write a big old query and just see if it works. And that didn't work on day one. So the time between that and the second implementation was nothing. We actually used the second implementation for a long time. It wasn't, we kept using each version until we hit a bug, right? We'd have a service owner say, well, I'm not getting SLOs for this service. And we went, oh no, you have more data than we can process. We need to go figure out how to solve that. And then the time between what I thought was the working version and the time that I actually had a working version was, I think, like 6 months. And again, the things that I say not working, every single implementation that didn't work was sort of it worked for 90% of the services, but not 10, or it worked 90% of the time, or not 10% of the time, where we had little blips. So it was never unusable to developers, but it was never really perfected. So you could describe what we're going through here as a series of iterations to get to something that was really reliable and well understood.
Got it. There is one more question. How do you deal with lag, right? Especially as it is a rolling window, if I understood it correctly, and the lag might increase with the downsampling approach that was taken in the later stages.
Yeah, that's a good question. How do you deal with the lag on the downsampling? I haven't actually, like I said, we didn't end up implementing it, so I haven't had to actually solve that problem. And I don't know. I think you just have to accept it. At a certain point, you have to accept that there's lag, or I'm sure there are. I've thought about this as well. If we didn't have any of these solutions and I didn't want to do the downsampling, if you do more on the aggregation side, and I don't think there's a way to do this. We use the Prometheus operator to scrape all of our pods. We have all our Go services running Kubernetes. They're running standard Prometheus exports. And if it was possible for Prometheus at scrape time to basically go to an endpoint, scrape all the metrics, and then do aggregation at that moment, then you don't have to deal with the breaks. You don't have to deal with, like, when that pod goes away, like, the aggregation isn't happening server side, it's happening scrape time, and you could not do downsampling. You could actually do aggregation at a place where you don't hit that problem with breaks and monotonicity. I don't think that that's actually a solution, but there are other kind of like middle layers that are, before it gets into Prometheus time series data, you do some aggregation that is safe and handles pods coming up and going down.
Perfect. We have one question in the chat here in Discord as well from Agni. He's asking if there is a validator for rules, particularly to scan or detect aggregation duplications, because they might be heavy. I think if Agni, if I understand the question correctly, you're asking about like linting or validating these rules so as to avoid duplicates.
Yeah, there isn't. That's an interesting idea. It'd be really, so I'm sure there's all sorts of Prometheus evaluators, but what you need, and I don't think Prometheus stores it, is you would almost need provenance for a metric series, right? Like in order to even run that, to say, here's your query, as part of this query, you're using a recording rule, and the recording rule came from this query, right? And you would do that down the chain, and so that you would have to be able to kind of take a query and know where all of its pieces of data came from in order for any tool to kind of evaluate that automatically. And to my knowledge, Prometheus doesn't have that. There are a lot of other like large data systems that do this, right? You have all sorts of other data systems that keep track of like where data comes from along the chain. But if you're writing a Prometheus query that comes from recording rule, the query treats a recording rule identically to a metric that was just scraped directly. So I don't think unfortunately, there's not like an automatic tool. The only thing I found is that little manual find and replace just to sanity test myself.
Right.
You can tell I'm a platform engineer. I'm trying to come up with like, well, how could I build this for an engineer so they can plug a query in and I can tell them that it's broken. I can envision it, but there's nothing built.
Okay. Perfect. Agni saying GPT perhaps, but I think this problem is not just related to SLOs, Agni. I think this problem exists for all other types of queries as well. Like it is not possible to even figure out if your alerting queries are duplicated or misconfigured if you're copy pasting and sort of generating those files. So that is a standard challenge with Prometheus which exists. We have another question on downsampling, Carson. So with respect to the request-based SLOs, especially when there is a downsampling rate, there might be a chance that you might miss a bad window, which will effectively impact the actual SLO calculation as well. Did you guys run into that kind of a situation? And if yes, then how did you handle it?
No, so I don't think we didn't end up doing the downsampling, so we haven't run into
Right.
that at this point. But yeah, you're right. If you're relying on those rules for downsampling and you miss it, then you can. It's an extension of a problem that already exists with just regular scraping, right? If you scrape every minute and you do a scrape, and then 30 seconds after your scrape, the service has a massive spike in errors and then disappears. And like the reality, like this is the trade-off that Prometheus has made. And you're right, the larger the windows are, the more they're likely that you hit one of these things. So like a downsampling every 5 minutes has a 5-minute window where you can miss a problem. But this is not, again, regular Prometheus has this issue where it's not trying to be 100% accurate. So I mean, it would suck, but I can see how that would be. It'd be something, it's just a trade-off you have to make, I think.
Yeah. We have one more question in the chat here in Discord. So Preeti has a question. Is there any framework to decide the compliance duration for internal services?
Sorry, can you mute yourself in StreamYard? I'm getting that echo. It makes it a little hard to understand and repeat the question because I didn't quite catch that one. Oh, yes. Yeah, so I think that goes a little bit down to picking objectives, right? Is what I think the question is about, is selecting what an objective for a service is. There's a whole section in the SRE book about, well, what is the objective? If I'm looking at a service, what do I want? And I don't think there's a lot of guidance. The SRE book is really good about giving you an idea of what they're for and not for. The difference is that, and this is the main thing with SLOs. SLOs are internal tools. They're not agreements that you make with the public. So they're often, I want to say, more realistic in their objectives. They're not the kind of numbers that you necessarily would want to put out in the world, because you might look at, especially when you get into like latency SLOs. Error budgets are pretty tight, but a lot of times when we're defining SLOs, we'll look at, say, This service generally completes all the requests in 100 milliseconds. But sometimes it has a certain endpoint that takes a minute to complete because of reasons. And that endpoint is called about 10% of the time. And so therefore our latency budget would say, well, we expect 90% of the requests to complete within 100 minutes, right? Because we know that 10% of them hit this other endpoint that's slow. And so those numbers don't look good to somebody they're not something you publish to the world that says, well, 10% of the time your thing is slow, but that's real performance on the service. So the way we generate these is we typically look at all of our other existing metrics. We figure out what is sort of standard operation for the service, and we have some tools and stuff that we built. There's no frameworks I know of that do this, but we basically look at existing metrics and say, based on current performance, this is where we expect the service to be. And then we kind of play with that budget, right? You don't want the budget to be past 0, but you also don't want it really to be at 100, because at 100 means you're not being very aggressive on your target. So we sort of evaluate constantly our objectives and move them. We're saying, well, you're really missing it, so we either need to fix the problem or shift the objective down, or you're always at 100. You can probably push your service a little harder to try to be more efficient or faster or have fewer errors, and not have that budget be at 100% all the time either. Hi. Sure. Yeah, there's 2 ways, and this talk focused on one calculation for the error budget because that's the one that we had most of our Prometheus scale issues. But a huge part of the SLO of any SLO system, and it's in the handbook, I just don't cover it here, is alerting. So there are 2 ways that our engineers use SLOs. One is they sign up for those objectives, right? They fill out the sentences and they hit go, and then when that budget, right? We're saying, well, your budget is at 90%. When that budget drops really quickly, or if that budget slowly starts to drop to the point where we're looking at the arc of the line and we're saying, look, if it keeps dropping at this rate, you're going to hit 0 pretty quick. And these are just calculations that are, again, outlined in the SRE book, that we generate these alerts automatically. So as an engineer, they plug in the sentences, they hit go, and then if they're ever in danger of missing those budgets, of going under budget, they get automated alerts that say, hey, something's going on. You said you wanted to hit this target. You're not on track to hit the target. And that typically correlates to some sort of spike in error rates or latency. So they get automatic alerts when they're in danger of missing a budget. And then we do use those numbers. One major idea of SLOs is I like to refer to them as that error budget as a measure of user patience, right? If you hit a service and it has a problem, you're usually fine with hitting it again, and as long as it works, you're fine. And then if you hit a service and it has a problem, and 10 months, a month goes by and you hit it and it has another problem, your patience is built back up again. And so error budget's really kind of, the lower that gets, you're looking at a service, you're saying, well, we need to make this major change to the service. We want to do a refactor, or we want to deploy it. How much user patience do we have to get this wrong, right? If that budget, as that percentage of budget remaining gets lower and lower, you have to really start looking at your planning for the service and say, maybe now's not the time to make this change, or maybe we need to address our other problems before even adding any more features to this service. So it's sort of alerts and planning are how those are used mostly. Yes. The SRE book does a really good job of describing this. You don't actually alert on exact values of error budget, right? The naive approach is to say, well, when the error budget gets to 0, that's an alert. You're more sophisticated, and again, these are the SRE book really, I mean, it outlines them in great detail, so I encourage you to look at that. But the SRE book has you alert on rate of decline of that budget. So you look at how fast the remaining budget is dropping, and based on that trend, it triggers, which allows you to have budget drop to really quickly to 0, trigger an alert. Budget stays at 0 for a while, maybe starts climbing back up, and then another incident happens and it drops well below 0. So by doing these alerts based on rate of change, you can re-trigger alerts even if the budget's already under 0. So yeah, you definitely, the SRE book really does a good job of step-by-step walking you through the ways of alerting. So we just plugged in the queries that they had from that book. Mm-hmm. Hey. Yes. Yes. So if you implement SLOs using like this is absolutely a problem. SLOs as a system don't generally work super well on low traffic services, just at all, right? So if you're looking at the service and you're saying, over the last 28 days, this service had 1,000 requests, it's probably not a good candidate for any SLO system. Even any sort of like, those low numbers make it really hard because a single violation is a huge percentage of the traffic. As like you say, well, this one request, we have 50% error rate. And you're like, yeah, you had 2 requests and one of them failed. Like it gets really hard just to deal with low volume. I will say that the queries that we're doing, and if I were to pop back here, right, if this kind of query is, well, not that one. Let's go to the one we're actually using. Okay, this kind of query is more tolerant of window problems. So I actually, we just hit this recently where somebody was doing their own mini version of, they weren't using our SLO system. They had written their own alert query, and the query said, hey, look at the number of requests that have happened in the last 15 minutes and divide that by the number of requests that have failed in the last 15 minutes. And it's basically the same formula, but just over a tiny window. And they would get alerts, false positives all the time, because it would be nighttime. They'd be getting almost no queries. They'd have one come in that failed, and in the 15-minute window, it would spike out of control. I would say that this kind of, the standard SLO queries, looking over 28 days, the larger that evaluation period is, the more tolerant the whole system is of these like minor blips, right? This is why just standard error rates are really not a good way to, I think the SRE book even talks about this, like the very easy error rate calculations don't work very well at scale because they're not tolerant of the bigger picture. And if your final SLO rules can take 28 days into consideration, like that's a big picture. That's a whole month of data. So it's way more tolerant of these small blips. So yeah. Mm-hmm. Yeah, it depends on what your agreement is, right? I would be really hesitant. If I was writing and I haven't written any before, but if I was going to write a service level agreement, I would be pretty clear that it's larger than, I would try to have it be within a large time frame, because you're right. If you have an agreement that says at any point in time we will not have any worse than this error rate, like that's really hard to reach, because low traffic periods, there's just no way around that. If you're saying, well, we'll never have more than 50%, let's say we'll say 99% success. We'll never have worse than 99% success rate ever for the service. I think you're just signing yourself up for failure in the agreement. If I had to stick to that agreement, though, let's say you can't renegotiate. That one of the tricks is, and this is an SLO book, artificial traffic. You can just say, downtime is coming, nighttime is coming. We're going to hit the system with a nonsense query every second to fill it up with artificial traffic and this sounds silly, but it's right in the SRE book as well. Like, that's one way to solve it, is just during your peak, your low periods, make them not have low traffic so that when those blips do happen, they're happening in this like pool. And I think that's a little cheesy, right? And maybe not in the spirit of actually solving the problem for the customer, but it would work. You would just say, we never have low downtime, because when it starts to shift down, we give it artificial load. So, yeah, it's kind of a silly answer, but that's real life for you. Sorry, I didn't get the question. Yep, I'm gonna go back out. Yeah, highly recommend the blog post. I know I talk kind of fast, so that post is really detailed. Perfect. Yes. Yeah. Yes. Yeah. No, and that's a good question. We started with, again, we wanted to do the whole thing with something that was hit the majority of our services, because they were those two protocols. You can do an SLO for anything, as long as you have the data and you can make the sentence statement. So really, really think hard when you're looking at other things about what impacts the user. You notice the thing about SLOs, they're very high level, right? Our HTTP and gRPC error rates are like, we don't care why. This is from the customer perspective or the user perspective. We don't care why your service had a 500 level error. It couldn't even be, it doesn't even matter if it was your fault, right? Maybe you had a 500 because someone else down the line returned weird data. To the user of your service, it still didn't work. So you take this idea of the view of the thing, and because we have a lot of message processing, right? So you can make an SLO for message processing by saying, what does the user really care about for messages? And for us, it is maybe, or it might be how long it takes for a message to get processed. And you make that objective statement and say, 99% of messages through our messaging system will get processed within X amount of time, right? Because to the user, if you throw a message on the system and it doesn't get used for like a day or a few minutes. So I think if you can write that statement, once you have that, you can look at the data you have and either use data you already have or figure out how to start tracking those numbers and then plug them into basically the same formulas. Cool. Yeah, that human understandable sentence is like the key to the whole thing. Ah, yeah, sure. No, that question was, how do you do SLOs? How do you take the SLO idea and extend it to things that are not HTTP or gRPC services? Mm-hmm. Yes. So yeah, so the question is that our windows are large. They're 28 days long, and have we ever had requests to reset and reset the budget? And this is a really fundamental part of the SLO idea. And I actually, that first half of the talk that I linked to with the red asterisks, I really cover the idea of this. And the answer sort of is no, is that we don't actually allow for a reset of that data. Like, your SLO budget will recover based on two factors: time passing and more usage, right? So we're looking over 28 days of data. If I have a big spike in error rates, my budget is going to drop real low, potentially, right? I have a ton of errors, my budget's burned up, it's in the negatives. The only thing that brings that budget back is the service doing more good requests, right? So that the number that we were putting in that formula is higher, or eventually the big error thing that happened at 28 days will fall off of the window and then you recover. There's no other way to do it. And that's by design. If you have this big error spike, you've burnt a bunch of your users' patience with your system, right? You had this massive thing, you had a major downtime event, people are upset, and they're the only thing that gets that confidence and that patience back is you actually performing well and time passing. So we've had occasions where people would like to they've asked us that, and it's like, you don't get performances, like there's no bonuses, we don't tie money to these objectives, these are management tools for us internally. And so no, if you have a big spike, you do have to wait 28 days or a lot of requests later for that budget to restore. But that really helps you look at the actual holistic view of the service and how people are feeling about it at that moment. Again, it's not a service level agreement. Which is why we're never trying to recover. Like, we're actually trying to measure real performance and real kind of experience from the user perspective. So hopefully that helped. Yeah, that first half really goes into, or that other talk that I gave really goes into detail about how the sliding window works.
Great. I think we're done with all the questions, and we're also out of time. I don't want to take more time from everyone. But thanks a lot, Carson, again, for doing this. Really appreciate this. We'll share all the resources, the blog post, as well as the recording as well with everyone. And if there are any questions, I'll make sure that I will pass those along to you. Also, you're part of the Discord, so people can ask questions here on the Discord as well. And yeah, we'll come with another session in next couple of weeks, something related to Prometheus and site reliability. So let's join back again. I'll announce the event in a couple of weeks, and we'll have it again. But yeah, thanks a lot, Carson. Thanks a lot, everyone, for joining, and see you soon.
Okay, thanks so much.